Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.3. So exercise 2.3 of O-level and IGCSE additional mathematics. And I don't think we need to introduce new concept right now because the thing is, whatever there is new in this topic, we've discussed it. So if we want to have a greater understanding, and if you do not understand what I'm doing right now, I would prefer you take my previous lecture on the starting of exercise 2.3, and that would clarify your concept. So let's just start from question 2 again. We have finished question 1 in the previous lecture. So question 2a, we have been given the equation fx is equals to 1 minus 4x minus x squared. And the thing is, I have to write this in the form a minus x plus b whole squared, which is quite easy for us. We have solved a whole exercise relating to this topic, so we should not have any problem regarding this. So rearrange this negative x squared, negative 4x plus 1. Again, take the coefficient of x squared to become positive 1. So take negative as the common, x squared plus 4x, and then positive 1 out of the bracket because we do not need it right now to be part of this x squared plus 4x equation. So again, what we do is negative x squared plus 4x as it is. But right now what we want to achieve is the equation x squared plus, a squared plus 2ab plus b squared. And to achieve that, we have a squared and 2ab in the form of 4x. Okay, we want b squared, and how can b squared become? By dividing by 2. So divide by 2, and of course a is x, we already know, so x would be cancelled down. So what we are going to say is plus 4 divided by 2 is going to be 2 squared minus 2 squared and plus 1. Again, we need this x squared plus 4x plus 2 squared part, not this negative 2 squared right now. So negative x plus b, which is 2 whole squared, minus 2 squared is negative 4. Negative 4 multiplied with the negative symbol so that it can be independent of this bracket and can move freely out of it. So negative 4 multiplied by negative become positive 4 plus 1. That's equals to 5 minus x plus 2 whole squared, and that's our answer. Again, what they have asked us in the second part is to sketch the graph of y is equals to f. So b, we are taking the function value to be the y-axis. So again, what we do is we already know the minimum and maximum point. So ax minus h plus k. So as we can see, negative h is equals to positive 2. Oops, sorry. Positive 2, h is equals to negative 2. And for k, we have k is equals to 5. So the thing is, the x value is negative 2 and the y value of the minimum point is positive 5. Okay, now what we have to find is some other coordinates so that it is easier for us to find the graph. So what we are going to do is say when x is equals to 0. When x is equals to 0, we are going to get the y value, and 1 minus 0 is equals to positive 1. Similarly, when y is equals to 0, we are going to get 2x values, as this is a parabola of a quadratic equation. So when y is equals to 0, negative x squared, negative 4x plus 1 is equals to 0. We have to make the coefficient of x squared positive, so x squared. In fact, we do not necessarily need it to be positive. I'm going to just directly solve it with the calculator. So it's going to be negative 1, negative 4, and positive 1. So two values of x. So x is equals to 0.24, or x is equals to negative 4.24. Okay, so these are the two values of x. Let me just check it if I'm wrong or not. So we have the values, and what we are going to do is just plot the values on the graph. So okay, so the thing is, we have done adjusting the graph, and what I've done is I've taken two values when x equals to -5, because one point is approximately at -4.24. So it's here, and one point is at approximately here. So I've taken -5 and +1, the x values for those, and then I've taken out the values. For both, we have the values -4. So what I'm going to do is I'm going to plot these points, -5 and -4, +1 and -4, and then what I'm going to do is mark my maximum points. So it's -2 and 5 all the way up till here, and I'm going to connect these points from here, from here up till here. Connect this like this, then here till here. I think I've made a bad graph. Let me just readjust this, something like this. That's good. And then from this point to this point, and that's it. So this is our graph for question 2, part B, y is equals to fx. And the thing is, in the third part, they've asked us to draw the graph of y is equals to the modulus of the function f. So again, we have discussed in the previous lecture, especially in chapter 1 in modulus functions, that whatever y value is, when we come across a modulus function, we make that negative y value into a positive y value. So right now we have 2 points at a negative y value, and those are at -4, -5, and +1. What we are going to do is reflect these points. So instead of -4, we are going to make this +4, so -5, +4, and this is it. Then what we are going to do is take this point +1 and +4, and then we are going to connect this line. I think line is more than, yeah, that's it, and this is it. So right now, if you want the real modulus graph, if you would draw it in your exams, you would draw just this part. You would kind of, I would prefer that you make the lower line a dotted line, by, you could erase it by just erasing some bits, from this part to this part, this part to this part. You can do that, but I can't do this in the virtual graph paper. So right now, for part C, this is what they are demanding us in real. So this is it. This is our part. Sorry, this is our question 2. So proceeding to question 3. Okay, for question 3, they have again given us a function fx is equals to 2x squared plus x minus 3. And we have to write fx in this form, where a, b, and c are constant, meaning they are numbers. So again, first step is to make the coefficient of x squared 1. So x squared plus 1 upon 2x. Again, you have to compromise, but you have to make the coefficient of x squared a1. Minus 3, because it's not important to take 3 in consideration for now. Okay, so 2x squared plus 1 upon 2x plus 1 upon 4, because 1 upon 2 divided by 2 is going to be 1 upon 4. 1 upon 4 squared minus 1 upon 4 squared minus 3, and this -3 is going to be out of the bracket. So again, 2x plus 1 upon 4, instead of 1 upon 4, I prefer to write 0.25 whole squared minus 1 upon 4 squared multiplied by 2. So 1 upon 16 is going to be multiplied by 2, which will give us 1 upon 8, and minus 1 upon 8 minus 3. 2x plus 0.25 whole squared minus, and I would give this in points. This is going to be 3.125. 3.125. And that's it. This is what they're demanding us for question number 3. Okay, so the thing is that we have to draw a graph again, because they have asked us to sketch the graph of y is equals to fx in a modulus. Thing is, what I would recommend you to do is to make graph of y is equals to fx first, because it's much more easier to draw a reflection when you know what the object actually is, if you understand what I'm trying to tell. So first, make the original graph. So right now we have less value. So what we're going to take is when x is equals to 0, y is equals to, or you can say fx is equals to y. So y is equals to 2, 0, 0 plus 0 minus 3. When y is equals to 0, x is equals to 2x squared plus x minus 3 is equals to 0. I'm going to take my calculator in order to solve this. So 2x squared plus x minus 3, 1 and negative 3 upon 2, which is negative 1.5. So x is equals to 1 and x is equals to negative 1.5. These are the two x values we need. Then, okay, what I'm going to take is, okay, just I'm going to plot these points first. So I have for the y, x minus h. So it's going to be negative 0.25 and plus k. So it's going to be negative 3.125. I am not wrong. Wait a second. I think there's a problem in this. Ax minus h plus k. Okay, let me just check. I think I've done a mistake or something in this question. No, I have not done any mistake. Okay, so we are good to go. Sketch these points on the graph. This is negative 0.25. When x is equals to negative 0.25, which is this point, we have got y is equals to negative 3.12. So negative 3.125 is going to be somewhere like here. Yeah, this is good enough. For the second point, we have x equals to 1 and negative 1.5 and y is equals to 0. So negative 1.5 is going to be this point and positive 1 is this point. And for the third part, we have when x equals to 0, y is equals to negative 3. X equals to 0, y is equals to negative 3. And that's it. What I'm going to take is, I'm going to take when x equals to negative 2. So that our graph is more detailed. It's really important to take more points you take, more detail you get in the graph. And if you have time in your exams, try to make your graph more detailed. It's really important. So negative 2 squared plus negative 2 minus 3. So 2 2s are 4, 4 2s are 8, 8 minus 2 minus 3. So minus 5, 8 minus 5 is 6, 7, 8. So it's going to be 3. Y is equals to 3. And for the second thing, we have when x is equals to, let me see, when x equals to positive 2. So we have 2 multiplied by 2 squared plus 2 minus 3. And that's going to give us 4 2s are 8 plus 2 minus 3, 8, 9, 10, 10 minus 3 is 7. So y is equals to 7. What we're going to do here is take these points. So let me just see. It's going to be positive 2 and positive 7. Go up here. Positive 2 and positive 7. And negative 2 and positive, negative 2 and positive 3. Negative 2 and positive 3. And that's it. These are our coordinates. We are going to connect these points first of all. Somewhere like this. And I'm going to extend this graph all the way up till here. This is going to be a little bit tricky for me. Let me just see here. And that's it. Oh, that was an intense moment for me. That's it. This is the graph of the initial part y is equals to fx. What we want to do next is reflect this part. So whatever the negative y values are, make it positive. So we have negative 3.125. It's going to become positive 3.125 somewhere here. Yep, like this. And again, when x equals to 0, y is equals to positive. So that's the second point. So we are going to make this a curve, connect these points like this. And before I connect these 2 points, I would prefer to connect these. And that's it. So this is our graph for y is equal to fx. And let me zoom in. So specifically, this is the graph of y is equal to fx. Right now, I don't have the option to erase. So, but still, this is the part of the graph we want. So that's it. Let's proceed on to question 4. Okay, for question 4, what we are going to do is it's different type of question from what we have done till now. We have been given an x minus 7 multiplied by x plus 1 in a modulus, and we have to find the stationary point of it on the curve. So the thing is, what we're going to do is first of all make this into a quadratic equation, and they have asked us the stationary point. And if you have seen the lectures carefully, you would have noticed we have found the stationary point from the equation ax minus h plus k throughout this chapter 2. So the thing is, we can also find the stationary point in this method. So what we're going to do first of all is to expand this up to make this a quadratic equation x minus 7 multiplied by x plus 1. So I'm going to use the FOIL method for now. So for the FOIL method, we're going to take the first, so x squared, but x multiplied by x is x squared. Outer values plus 1 multiplied by x is equal to x. Inner minus 7x, and last minus 7 in the model. So y is equal to x squared plus minus 6x minus 7 in a modulus. And what we're going to do is to make this into the form ax minus h plus k. So we have done this method tons of time throughout this chapter. So x squared minus 6x plus 3 upon 2 whole squared. So 6 upon 2 whole squared, sorry. So 6 upon 2 whole squared will be 3 squared minus 3 squared to balance this up, and minus 7. Okay, so if you just simplify this and factorize this into the form a minus b whole squared, we are going to get we are going to get x minus 3 whole squared minus 3 squared is equal to 9. So minus 9 minus 7 in a modulus. So that is equals to x minus 3 whole squared minus 7 9 16. And the thing is, we have throughout this equation, if we compare this, minus h is equal to negative 3 and negative 16 is equal to 2, and h is equal to 3, negative 16 is equal to 2. The thing is, if you take the equation without considering the modulus for now, we would have got the stationary points to be x equals to 3 and y is equal to negative 16. However, we have it trapped in a modulus, so that answer would be incorrect. If it is a modulus, we would only change the we would only change the negative y value. So instead of negative 16, we are going to write positive 16, and that would be the correct value. Another fact is that take care, by the way, that for example, if you have negative 3, it's not in this case, but for example, you had negative 3 in your answer. You would have copied this negative 3 directly into this, because we only changed the y value, the negative y value, into positive in when considering a modulus. Okay, so this is the answer for part A. For part B, they've asked us to sketch the graph of x minus 7 x plus 1. So what we're going to do for that is go to our graph paper, and first of all mark our coordinates. And before we mark our coordinates, by the way, let us make more detail. So for some more detail, we would need some more coordinates, and some more coordinates will come when we find out the intersection of x on the x-axis. That's really important in forming the graphs of quadratic equations, the intersection at the x-axis. So when does those intersection come? So when y is equal to c. So we are going to get x squared minus 6x minus 7. That was the equation, yes. So we are going to open this up is equals to 0. Solve this quadratic equation up. So we are going to get 1, negative 6, and negative 7. That's going to be 7 and negative 1. So x equals to 7 and x equals to negative 1. Similarly, we do for the when y is equals to 12 and x is equals to 0. So when x is equals to 0, y is equals to 0 minus 0 minus 7, so y is equals to negative 7. Again, this is a modulus graph, so this point will turn into 0 and positive 7. Negative 7 will become positive 7. Okay, so what we are going to do is take our freehand tool, mark one point at negative 1, mark one point at positive 7, mark another point when x equals to 0, y is equals to positive 7, and mark our last point at when x equals to 3, y is equals to positive 16. And that's it. Then mark the points. What I do want to know is when x equals to negative 2 and when x equals to 8, because that's going to make our graph even more detailed. When x equals to negative 2, we are going to get y is equals to negative 2 minus 7 is going to be negative 9 multiplied by 2. Negative 2 plus 1 is equal to negative 1. That's going to be positive 9 even after modulus. So it's let's mark this coordinate. Positive negative 2 is going to come with positive 9. So here's our point. And when x equals to 8, we have to find that point also. Let me just make a space in between. When x equals to 8, y is equals to modulus of x minus 8 minus 7 is negative 1. Oh, sorry, positive 1. And 8 plus 1 is equals to 9. So again, this will be y is equals to 9. So again, go up there, 8 and 9. Okay, what we are going to do, we can connect these two coordinates with a line tool. It's not a big deal for this one. Let me escape this. This is complete for now. And this one and this coordinate, let me first of all make a curve. I think there's a problem or something. Let me just sketch this up. Make a curve. Connect these points. Let me just see. Yeah, I marked one point incorrect. I'm really sorry for that. I just saw it right now. Let me just correct this up before I do. I'm really sorry for that. Freehand tool, when x equals to negative 1, negative 7, sorry, positive 7. When x equals to 3, then y is equals to 16. Y is equals to 16. When x equals to y is equals to 7. And that's it. Negative 2 and positive 9. And positive 8 and positive 9. Okay, now we are going to connect these points with our curve, something like this, and beautiful curve like this. This is going to come and connect like this, and that's it. For the this is going to be basically a straight line. Wait a second, yes, and same for here. This is a straight line. Okay, so this is the graph for question number 4, part B. And what they have asked us in part C is we have to find the set of values for which x minus 7, x plus 1 is equals to k, and they told us find the value of k. So it has 4 solutions. So basically what they are saying, I'm really sorry. So what they have done is they have replaced fx, or you can say the y-axis, with k. So they are saying that find the set of values of k. They're telling us that tell us the values on the y-axis, as you can see here, for which we have 4 solutions, meaning we have 1, 2, 3, 4. And you could have guessed till now that what I mean is they are asking us to find a point on the graph for which when we take the corresponding y value, we get 4 numbers of solutions. So for this value, we have for y is equal to positive 6, we have 1, 2, 3, and 4 solutions. Let me use a freehand tool for now. 1, 2, 3, and 4. So the thing is, they're asking us to find out the value of the y values for which we have 4 solutions. And how can we find that out? So we know this line is extending, and I have just made it somewhere like here to make it detailed as per me. But this graph is going straight, and this line is going above. this line, you can say this line is kind of unlimited. So it's really important to take in consideration that this line is unlimited. Okay. By this line, I mean the line which is before the curve is starting. Okay. So this straight line remains straight. What we are going to take in consideration is the fact of the maximum point. So we've learned in the in exercise 2.1, I guess, yes, that whatever point is above the maximum point or minimum point, we are going to get two solutions for that. Whatever is above the maximum or minimum point. So we are going to get above or below value. So we are going to get two solutions for that. And as you can see here, whatever is right on the point where the maximum or minimum point is, we're going to get three solutions. As you can see here, 1, 2, and 3. Whatever is between the maximum or minimum point and the y value of 0, we are going to get 4 solutions. As you can see here, any value you go through, for example, even if I go through positive 1, we are going to get 1, 2, 3, and 4 solutions for it. Even though they are close together. Even in 0.5, if we just zoom in right here, we are going to get 4 solutions. And when when the y value is 0, we are going to get 2 solutions, as you can see here, because they are intersecting at this point. So 1 and 2. And so we can say that whenever, wait a second, whenever whenever the y value is greater than 0, but lesser than the maximum point, in this case, we are going to get 4 solutions for k. So our answer would be, so what is the y value of the maximum point we have? It's 16. So we are going to say that for part C, k is actually greater than 0, but lesser than or equals to 16. And that's our answer. Wait a second, let me just check if I am correct or I am wrong in this case. However, I think this is the correct answer. So yeah, 0 is k, or it's, oh sorry, by the way, this is not k greater than equals to 16. It's lesser than 16. The reason why is because if we go on equals to 16, we are only going to get 3 points. So it's lesser than 16 only. So this is for question number 4. Proceeding to question number 5, and before I proceed to question 5, let me just erase this graph. I think this is clear out. Yes. Okay. So for question 5, what they're asking us is to find the coordinates on the stationary point of the curve y is equals to x plus 5 and x plus 1. So as we have done in the previous question, we are going to solve this up, x plus 5 and x plus 1. So what we're going to do is take this value and solve this up. First of all, y is equals to 1 multiplied by, sorry, I took the modulus as 1. So first, as we are going to follow the FOIL method. First is going to be x squared, outer is going to be plus x, inner is going to be positive 5x, and last is going to be positive 5 itself. And this is trapped in a modulus. So y is equals to x squared plus 6x plus 5 is equals to, plus 5 in a modulus. Okay. So what it's going to be doing next is take this into the form ax minus h plus k, and that will help by x squared plus 6x plus 6 divided by 2 is 3, so 3 squared. And to normalize this equation, so we are going to subtract it from negative 3 squared. So plus 5 and it's trapped in a modulus. And to factorize this, we are going to take this up, x plus 3 whole squared minus 3 squared is 9, so negative 9 plus 5 in a modulus. So y is equals to x plus 3 whole squared minus 9 plus 5, and that's going to be minus 9 plus 5 is negative 4 in a modulus. So again, compare this up. So negative h is equals to positive 3, h is equals to negative 3, and y is equals to negative 4. Okay, and the thing is, this is trapped in a modulus. So what we are going to do is turn the negative y value into a positive y value. So instead of negative 4, we are going to write negative 3, positive 4. And the reason why I'm not changed -3 into positive is that we don't change the negative x values into a positive value in terms of a model. So that's it. This is for question 5 part A. What they asked us in part B is find the set of values of k for which x plus 5, x plus 1 in a modulus is equals to k has two solutions. So what they are asking is basically, again, So again, they are asking us that find the set of values of the y value, find the set of y values for which the graph has two solutions for the following quadratic equation, x squared plus 6x plus 1. Now you could have drawn the graph and done a really long thing and all, but the thing is, we all know the basic concepts. We know that when there's two solutions come, whenever we cross the maximum or minimum point, that solution is going to come, or whenever we are going to cross the whenever the y value is 0, we are going to get two intersections in the form of the intersection on the x-axis. So basically, what we have asked us to do is we are going to tell whatever value. So our graph is going to be something like this because it's a modulus, and we do know that the maximum point y value is 4. So we are going to say that the maximum point for k, which k has two solutions, it's actually for the graph, its k is greater than 4. So whenever k is greater than 4, we are going to get two values like this and this. I'm just trying to visualize it. It's not an accurate value. Another point when you would say is when k is equals to 0, or you can say the y value is equals to 0, there are going to be two intersection points. So again, yes, we can say or k is equals to 0. So that's it. We are going to say that either k is greater than 4 because it passes the maximum point, then it would have 2 points, or k is equals to 0. By the way, you can add in a bracket because intersection of on the x-axis. Okay, so that's it. This is for question 5, and I'll meet you in the next lecture with the rest of the exercise 2.2. I hope you like it. Thank you.